Okay, so we're going to continue on now, and we're going to do a bit of our thread programming, and this allows us to receive continuously as a separate thread for our client networking aspect here with our server. Our server is here and running already. Now, what's going to make this work properly is the fact that we need to set up, first of all, we need to set up our thread. And you'll find that the actual, since we've done this to a class, it makes it way easier. Oh, that brings up another point. We do need to include both our window and our network.h file as part of our main file here. So you'll need to go into here and put in a pound include here, and then in quotes put chatwindow.h in quotes. And over here we're going to do pound include here space quotes client network.h in quotes, and save it. And this will allow you to basically make use of these libraries. It basically includes them into this file, if you will, without having to have them written out in this file. So it shortens your code and makes life easier. And we'll be moving more and more of our stuff from this file into separate files like this to simplify the project and make life easier to read and find different things. So now when I'm only interested in the chat window part for the code on it, I can only have to look in the chat window, and I don't have to look all over the place. That's very nice. Same thing goes for my client network code. Alright. So, continuing on, let's scroll on down, and don't worry about the sound stuff yet. We'll have that in another video here. This is more advanced. We'll get into that later. More advanced for the sound system with a full audio mixer system. Has 3D sound and all this stuff, but don't worry about that for now. I'll cover that in another video, so just ignore all that code. You don't need it at the moment. Okay, so game chat window here, space, my chat window, semicolon. And this sets you up with your window, your chat window. That right there creates the chat window. That was it. It's that simple. So it's pretty nice. And again, that's why we want to, it just becomes a variable, and that's it. It's that simple. And because of that now, you can see why these classes are so powerful. We did all that code just so we can do in one line, we can just declare that chat window. I want another chat window, I just simply do game chat window space, and then, you know, the name of the chat window I want for my variable here, semicolon, it'll make another chat window. Ta-da, that's it. So it's really simple, it's really awesome, and really powerful. Indeed. Okay. So let's set up a thread. Alright, to create my thread, I needed to create an SDL thread pointer, more or less. This is my SDL thread function. This is my SDL thread pointer. Good thing to point out, because you have to have both. SDL underscore thread here, star. Space, and then network receive thread, semicolon. Now, you need to have thread included somewhere in this whole mess. So here we have SDL underscore thread here. This needs to be added to your list of library files that you need to include. This is part of the main SDL, but if you want thread functionality, you have to include it. Also note that threads may not translate well across all platforms, because threads become significantly different in Linux versus in Windows or Mac OS X. Well, I guess between Mac and Linux it's not that significantly different, but it is significantly different between Windows and Linux. So be aware of that. Be careful of that. Okay. Now, with that said, we'll move on. Okay. So this sets up our thread, and I wanted to say network receive thread, so I knew it was the network receiving thread for receiving information from the server. It's just kind of straightforward in the naming, so now I don't have to worry about understanding what on earth some variable does. Basically, And then I'm doing an int. It has to be an int for your return type. Always has to be an int. So make sure it's an int. Receive messages. And what the int means is totally up to you what you want it to mean. But it does have to be an int. That is a requirement. Open parentheses void here, star, close parentheses, semicolon. Now if you want, you could even do something like data in here. Or some kind of variable, if you like, where you can pass in something into this function, but you have to do it like that. And then the data has to be recasted inside of the actual thread, and that's because this is a callback function actually. And it's basically what a thread function is. It's a callback function in C. So I'll get into that in just a second. Okay, so also there's mutexes. If you want to have a mutex, you create a mutex pointer that way. And mutex is a way of, well, it's the most simple control possible for a thread, but it basically lets you lock and unlock a thread, where if you lock it, you say, okay, nothing's going to happen in this thread while it's locked. And then when you unlock it, the thread executes again. So think of it as like pause and play for threads, if you will. A mutex basically lets you, pause it with a lock, and then unlock it, makes it play, more or less. Or shall we say execute and not execute. That's it. That's all there is to a mutex. It's that simple. But yeah, you have to create a pointer to the mutex so that way you can access it. Okay, so with that set up, let's scroll on down to our main function where it's being implemented. Okay. Oh, and I did comment out my CD stuff here because I was getting a lot of status messages, and it was screwing up my ability to see what was going on in my execution here of my program. So because of that, I wanted to see just what was necessary and nothing more. Particularly because when I type, you can actually see what keys I'm pressing when I'm typing out stuff here, because they're getting displayed as such. And then when I send that off, server says the test or whatever. So you can see I get back response messages, and it just made it easier. If I had that constantly just updating and spitting out information, then it wasn't all that useful to me, I'm afraid, because I wouldn't be able to see the server say the test here coming back from the server. I can see it in my window here though, so pretty much know that I'm good to go. But just for extra clarity and just makes it easier to make sure I have everything working properly, I'd like seeing those messages pop up in this message window here. Okay, and I couldn't do that otherwise. So with this going on, because it was just kicking out so much information, it was wiping over it more or less. It scrolled past so quickly you couldn't even see what was said. So for that reason, I commented it out. There's nothing wrong with it. It's not like it's not working or anything like that. It's just that I commented it out in order to make life easier. Basically, that's it. Okay, so with that said, let's look at what we have going on here. Okay, so we're not going to worry about our sounds here, so please ignore all the sound code here. Alright, so SDL underscore show cursor, SDL underscore disable, close parentheses, semicolon. We must disable our cursor, or otherwise we'll end up with dual cursors basically. And see how I'm moving the cursor here and I'm getting this cool ogre cursor? Well, if I didn't do that disable, see how I got two cursors here? It'd be two cursors everywhere I move my mouse. And that's due to that dual cursor problem here that I was talking about just a second ago here. You can see how the window is very transparent here. And that's by design, but okay. And so that sets up the disable. My chat window here dot create CE GUI window open close parentheses semicolon. Okay, so that sets up the chat window and creates it to be formed in the viewport. So that makes it all happen right there with that create. Alright, so next thing we need to do is set up our thread. Now that our window's created and we have something established, we need to be able to receive messages back from the server after. But before I could do that, I had to have this window created, right? Because I'm going to be sending and receiving messages with that function. And we'll get into how that function works in just a second. But that function does use something from this window. And so because of that, it's important that we make use of, we actually create this window before we start trying to make calls to it, more or less. And that's exactly what this function does. The moment we create this thread, this function executes and it's live and starts running as its own thread and its own process. And the execution will go past this thread, but it'll still keep running in the background continuously. If you have multiple cores, this will literally run on another core. So this is how you can get multi-core processing done in an application. So this way you can have, say you have asynchronous execution, or shall I say, another way of putting this is that say you have two totally independent processes that can run from each other to do something in the system. Well, that's cool. That's a great application for threads. So this way you can have it run off in the background and not have it mess with everything else. And you can still have it communicate back with the rest of the system through intermediary variables. You have to be careful though that you do not want multiple threads accessing the same thing in memory at the same time, as it will be a problem. And if that is the case, then you need to lock and unlock the different threads so that they do not fight with each other for resources of the system. So that's where it gets kind of complicated with threads. If you have more than one thing accessing the same object in memory at the same time, because it can crash the system. So be careful of that, or crash the thread. So, or your application or whatever. So be careful of that. That is an issue that you have to deal with when you're dealing with threads. But the cool thing about a thread is like I said, is you can have multiples of these executing at the same time. Now in the later series we're going to be getting into OpenCL, in which case in OpenCL we can handle millions of threads or billions or trillions of threads simultaneously. And that's amazing. But you can do that. You can do these lightweight threads. And in this way you can actually handle tremendous amounts of computation simultaneously. And of course it always works better if they're asynchronous, meaning that they can run independently of each other and don't require information from each other in order to operate. So I guess one good point of making that I can make on this, say you have some calculation you're going to run through a loop, right, on these different parts for an array, like an array or a vector, right? Well, in the case of threads, you could simultaneously process all elements of that loop at once by assigning each part to a thread. And I don't know if that'd be the ideal thing to do as far as SDL, but in OpenCL it would be. And you could definitely do that and divvy that up easily. And so we're going to get into more advanced multi-threaded programming for parallel processing later on in another series here with OpenCL. But for now, this is really good as far as the which is what we can do with some threads here is very useful for multi-threaded programming within the application here inside of SDL. It certainly makes life easier. So that's what we're going to go with for now. So we're going to receive messages from the network and a whole nother thread running in the background. And we don't have to do anything while we're waiting for that. Okay. Now, how to create a mutex. So this is that locking mechanism I was just talking about, or pause and play, if you will, for a thread. So you would create the mutex like that, and then you would lock a mutex this way. And then you can unlock the mutex that way. And this way you can lock and unlock threads. If I want to, I can even tell a thread for us to wait until the thread finishes. Of course, this isn't too cool because if you have to wait for a thread to finish for its execution, then essentially you are going to hold up the entire application until a thread finishes its execution. Now that may be required. Maybe you can't go on to the next part of the process without having that thread finish in the background first. But if you can, of course, you're better off. And so this is where you can get into application slowdowns when you start waiting for threads to finish. If a thread continues to go on for a long time and doesn't finish, you can kill it. You can massacre threads if you so desire. So here's an example. By the way, SDL has a great set up here for their documentation on the different parts of the threads here. If you just go into the wiki for SDL lib, you'll find all kinds of wonderful information. And in here you can see all kinds of different things for mutexes and semaphores, etc., etc., etc. And that's very useful. And here's the actual file for SDL threads as it's laid out and defined. So if you want to, you can go and look at the code. There's not much to it, thankfully, but there it is. I totally didn't mean to do that. I think I saved it. Okay, well, there we are. And this gets into thread, synchronization, etc. Besides the fact that you can make them wait and you can destroy them, you can also destroy semaphores and mutexes too. After you're done with it, you can make it be destroyed. Here's the Semaphore Wait. Semaphore is like a conditional mutex. It's a more advanced one. And basically what it allows you to do is the same thing as a mutex, but you can take other, well, let me show you. I guess that's the easiest way to say it, right? Create semaphore. Okay, so as you can see, you get your initial semaphore value in here. You create your semaphore. And it goes into your semaphore, and then you have to create that pointer though first off, just like a mutex, pretty much. Yeah. And so you get a value in there. And this does allow you to lock, but well, so each locking operation on the semaphore by like sim wait, sim try wait, sim wait timeout. Yeah, you can make them timeout too. Will automatically decrement the semaphore value. The locking operation will be blocked if the semaphore value is not positive, so greater than 0. Each unlock operation by the SDL sim post will automatically increment the semaphore value. Okay, so basically this has like a counter system on it, and once it reaches 0, it can no longer be locked. And so you can't lock it, but if it reaches a certain point here, every time you do a sim post, it's going to increase that value for its for being able to be locked, if you will. But if you have it, you can have it time out, you can have it decrement automatically for the value, etc., etc., etc. And so they got a really sophisticated way of doing management basically with semaphores compared to mutexes. There is a way to do more sophisticated control over a mutex, and that is by using these conditions that they're talking about here. And these conditions will allow you to make conditional control over a mutex, just like pretty much a semaphore is. Think of a semaphore as like a combination of a mutex plus conditionals in it. And the conditionals, I think, really exist mostly for mutexes to make them more robust and powerful. You can do however you want. You know, it's really up to you how you want to go about it. But there you see a semaphore post here. So semaphore is a little more complicated, and increments the semaphore count here. So, or a negative error code on failure. Okay, blah blah blah. And so you can see here we're just doing the post here on this, and they're passing in a semaphore pointer to it. So just like this. Right, and then that increases your so post unlocks the semaphore pointed to by sim and automatically increments the semaphore's value. Those that were blocking on the semaphore may be scheduled after this call succeeds. So there you go. Semaphore post should be called after a semaphore is locked by a successful call to sim wait or sim try wait, etc. or sim wait timeout. So I'll get into showing this later on, how we can make better use of semaphores and mutexes. I don't want to get into an entire series on it right now, because this is a more complicated topic, but I do want to show you basically a working example of code of how this works. And you can feel free to go back through here and look at some of these here just to get a better overall idea and overview of these different parts. Okay, so I'm not interested in making my thread wait, and I'm not interested in doing a mutex. So I'm going to comment those out. And I only created these for the purpose of this video, so you can see how to go about it basically. And Semaphore follows mostly the same way a mutex does in this manner, but it's more complicated because it's got that conditional element to it. And we'll get into more advanced thread handling here later, as it'll be really useful, no doubt, as we do more and more with this application. And I do want to get into a larger discussion of it because it'll help us with the OpenCL later on too, because you'll have some idea of how threads work at that point. Okay, so this executes this callback function, which is receive messages, and we're not passing any other data to it, so it's just going to be null. Okay, so let's have a look at that callback function. So if I scroll up, we'll find receive messages right there. And it's int here, first return type, receive messages, void star here, and in parentheses. We have open close curly braces here, and then while, I just have it set to return 0 from the return type here, while open parentheses, not my chat window dot network dot done, close parentheses. So we're going to continue the loop while the network thread here is still good, or not network thread, but network object. Network object that's part of the my chat window object. So while this is good to go, because remember, right over here back in our client, we coded it up to where done is true if we send out to disconnect from the server. So if we go to disconnect from the server, it's automatically going to have it to where it ends this loop. Once the loop ends, the thread ends, and thus ends this thread. So I do have thread management here. I'm just not doing it explicitly with mutexes and semaphores and conditions. Instead, I did it kind of underneath the hood with the actual class definition, and it just made it easier because this will just get passed in at any point in time during the execution of the program, and this allows me to sync this with the rest of the application easily. So I just like this method, and that's why I did it that way. And it works fine. Works really good, matter of fact. Okay, so open and close curly braces here. My chat window dot output text. Now remember, we already created this window beforehand, so now I can make a call to this window. That's why we had to do that create window first before we did our call to our thread here. Calling that, we made our window and created it here. So that's why, because we had to make a call to this output text. And then in output text, I'm saying servers say space colon, because I'm receiving something from the server. So I want it to tell the difference between the server saying something versus what I'm saying in the window. So I can easily tell it apart. And then I have a space here, and I have quotes, and there's a colon here. Plus, this is going to do concatenation between my strings. And so I do my chat window dot network dot receive open close parentheses comma, and this will let me receive messages from the server. All right. CEGUI colon color in English style for a color spelling. 0.0f comma 0.0f comma 1.0f. So this is OpenGL formatting. We have to have the F's here at the end of each number, and basically this lets us colorize it. So it's red, green, blue, and this lets me set the blue color for the OpenGL. Close parentheses, semicolon. And in this way, we're able to do OpenGL coloring of our text, and it comes out blue. Now before I didn't have that set that way, so it was coming up white. But when I set this to blue, the whole thing came out blue. It's great. Close curly brace, return 0, and then semicolon, and then close curly brace. And let's run this application and see what happens when it receives a message from the server. had to hit the backspace key. Mistyped. There we go. So you can see what goes into the basically into my chat window versus what goes over here for the server. And it automatically created a scroll bar the moment I went too far. No problem. It'll also generate a scroll bar automatically for the vertical, up and down. So there we are, and we have a running, working chat system with client and server interactivity. Beautiful. And that concludes the code, but not going to conclude something you need. You also need tiny XML. So let's look at that real quick. Yes, it doesn't end. Alright. Okay, so over here, packages.ubuntu.com/source/maverick/tinyxml. Alright, so you can download these. And if you just break off each one by right-clicking on these and saying new window, you can download all these Debian files, .deb. And if you download them, you download them from the architecture that you're looking for. In my case, mine's AMD 64, but yours may be 386, it may be whatever. I mean x86, saying a 32-bit versus 64-bit, let's put it that way. This is 64-bit, this is 32-bit. And so you would need to, before you can install dev though, there is an order, so you can download them all, but there's an order at which you can download these, right? So you need to download like regular XML, and you need to download the doc, and you need to download the debugger and install them first, the regular one, then the doc, then probably debugger and dev after that. And once you do that, then you can, yeah, indeed you can actually install that Debian file. The reason I had to do this, depending on which version of Ubuntu you have installed, on my 10.4 I was not able to pull it up in Synaptic Package Manager. If you do, if you can, go Synaptic Package Manager and type in tinyxml, and it may just appear for you. But for me it didn't. So because it didn't, I'm going to showing you how to do this by downloading these actual Debian packages and just installing them. Once they download, it'll go to your, it'll pop up in your downloads here. And once that happens, then you can just go in here, and you can see it right here. Same thing for me. And all I did was double click these. And when I double clicked them, it installed them. It was that simple. And I also downloaded the all one too, which I don't think they have in here. But there is an all one somewhere. But anyways, that worked out fine for me. So FYI, that works great. And that is how you can get them. If you need to, you can also search for other places that may have them too, with using Google. But that worked out for me. Okay, so once you got that installed, there's one other thing you have to do. And that is that you have to come in here and we're going to change directory into where we did our building for our CE GUI. Alright, and I'm going to change into CE GUI, star, like so, ls. And we have our configure, -- help. -- help is going to be very helpful, in fact. Because if you remember right, we have to do -- disable here, dash, oh, I can never remember now. Devil. To disable devil. But now we have to disable several other ones too. Because the problem we'll have, I'll show you what's going to happen. The problem I have is that, well, alright, fine. The problem I have is that too many of these other XML ones are installed on the system and working fine. But the problem is that they end up causing some problems for compiling. So in order to get around some problems, you can simply, if you do have problems with some of these XML ones, and you want to just use tiny XML, then we can get around that. Now literally, xers, parser, and all these others were a problem, so in order to remove them, we literally have to tell it to not do them. Okay, so if I remember right, I'm going to try to do some of this off the top of my head. Which is usually not a good idea. But anyways. I think it was xers-c. See if I'm right or wrong on that. And then all the others were just straightforward. Yes, it was -c. Okay. An expat and an XML libxml are just straight up what they are. So if I want to disable them, it's straightforward here. So libxml. And then if I want to disable the other one too, which is expat, just expat, like that, then I can disable those too. Like so. Okay, and end up with tiny XML parser here for my parser. At this point in time, I configured it. So now all I have to do is sudo space make, and I can rebuild. And then afterwards, I'm done rebuilding again. Then you should be familiar with this at this point in time, right? Sudo space make install, like so. And after that's done, you're going to do ld config, like so. Bam, and that's it. And it updates the system, and you should be good to go, ready to compile from over here. And that's it. That's all you have to do. So with that, that should get you to where you can actually run your network client and server from here. And then I'll go into more depth on threads and also do the SDL mixer here in the next set of videos, and then we'll dive into more depth into C++ class architecture, and also we'll get into Crazy Eddie's GUI for doing node-based Windows systems, which is really cool and powerful. And in the next training series, with the CG training series, we're going to add on with those node-based Windows, and we're going to allow it to where you can basically generate shaders in a node-based shader architecture here inside the application. So because of that, you can download, you'll be able to do your own node-based shading with this. Alright, so with that, that covers basically client-server networking programming in Linux, Windows, and Mac OS X, basically, with SDL and Crazy Eddie GUI and a number of other things. My name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.